Hi, today in this case study video we are going to see about the mission to Mars, Mangal. Mars Orbiter Mission, India's first interplanetary mission to planet Mars, was launched on board PSLV-C-25 on November 5, 2013. ISRO has become the fourth space agency to successfully send a spacecraft to Mars orbit. Though the designed mission life is 6 months, Mars Orbiter mission completed 7 years in its orbit on September 24, 2021. The objectives of this mission are primarily technological and include design, realization and launch of a Mars orbiter spacecraft capable of operating with sufficient autonomy during the journey phase, Mars orbit insertion, and in orbit phase around Mars. MOM carries 5 scientific payloads to study the Mars surface features, morphology, mineralogy, and Martian atmosphere. The 5 scientific payloads are Mars color camera, thermal infrared imaging spectrometer, methane sensor for Mars, Mars exosphere neutral composition analyzer, Lyman alpha photometer. Based on our understanding of Mars, which was thought to be probably a warm and wet planet earlier, is now seen to be dry with a thin atmosphere. How this evolution has taken place is still a topic of research. The Mars color camera is a versatile and multi-purpose snapshot camera with RGB Bayer pattern to map various morphological features on Mars and return visual images of Mars and its environs. Besides providing context information for other payloads, MCC is also expected to observe and help in further our understanding of events like dust storms, dust devils, etc. that are known to occur in Mars. This payload is developed by Space Applications Center, Ahmedabad. The main objective of the Mars color camera, therefore, is to map various morphological features on Mars with varying resolution and scales in the elliptical orbit, to provide context information for the other scientific payloads. Methane sensor for Mars. The primary science objective of this payload is to detect and measure methane concentration in Mars atmosphere under clear sky conditions. Other studies which are possible are measure spatial variations in CO2 column density by pressure to understand dynamics of Mars atmosphere. Measure reflectance of Mars surface in spectral range 6030 to 6090 cm by sun. The methane sensor for Mars is a differential radiometer based on Fabry-Perot ethylene filter operating in short-wave infrared region. There is absorption of CH4 in the first channel, whereas no absorption in the second spectral channel. So the differential signal gives a measure of column amount of CH4. The thermal infrared imaging spectrometer is a gratitude-based spectrometer which will measure the thermal emission from Mars surface. The data acquired by thermal infrared imaging spectrometer will be processed and analyzed in order to map temperature of Mars surface. This spectrometer operates in the infrared region of 7 micron to 13 micron. TAS has been configured with an uncooled microbolometer array that saves significantly in terms of weight and power when compared to a cooled IR detector. The main scientific objective of the Mars exosphere neutral composition analyzer is to study the neutral composition and density distribution of the Mars exosphere and to study its radial, lunar, and possible seasonal variations. This would help in understanding the escape of the Mars atmosphere. MENCA is a quadruple mass spectrometer consists of a filament detector and associated electronic systems. A suitable combination of radio frequency and DC voltages are applied to the alternate pass of quadruple rods to accomplish the mass separation and thereby the determination of partial pressure of species. Also, MENCA has an inbuilt pressure gauge for the measurement of total pressure. In addition to acquiring the mass spectra in a specified mass range, The instrument has a provision to study the time evolution of a set of selectable species in the trend mode of operation. The uniqueness of this mission is highly elliptical orbit geometry of MOM enables its camera to take snapshots of full disk of Mars at its farthest point and finer details from closest point. First time observation of the far side of Deimos, one of the moons of Mars. Achievements so far. The Mars Color Camera, one of the scientific payloads on board MOM, has produced 1100 plus images so far and published a Mars Atlas. India's ability to successfully realize the complex mission to Mars in its first attempt in a cost effective of Rs 450 crores has captured the world attention and has propelled India's image as a credible space-faring nation to greater heights. Mars Orbiter mission is a mission of national pride which has attracted the attention of students, general public, media and international science technical community. Importantly, Mars Orbiter mission has created enthusiasm among the younger generation in the country, provoked to the curiosity to understand and discuss space-related techniques and maintaining the tempo throughout the mission. Major science results obtained in these missions are the solar coronal dynamics during the post-maximum phase of the solar cycle 24 using S-band radio signals from the MOM. Mars exospheric neutral composition analyzer observations has shown for the first time that the abundance of oxygen exceeds that the carbon dioxide at an altitude of 270 kilometers during the perihelion evening hours. Atmospheric optical depth was estimated through Mars Color Camera. Observations and the studies reported the presence of Lee wave clouds above the southern wall of whale moraines. Enhanced escape of Martian atmosphere during global dust storm. Changing gravity can cause fluctuations in the blood pressure, particularly during re-entry to Earth or landing, and can even cause unconsciousness sometimes. Assessment questions are given in this slide. And thanks to ISRO for providing these informations. Thank you.